In this video, you're going to learn about sequences. First, we're going to define them, and then we're going to talk about how we can find terms of a sequence and apply them in some realistic problems. So let's start off with what in the world is a sequence. So a sequence, first of all, is a function whose domain and if you recall, a domain is the set of inputs, right? This is what you're allowed to plug into a function. So it's a domain whose inputs is the set of consecutive integers. So those consecutive integers, of course, we're going to start with 1, 2, 3, 4, so on and so on and so forth. So to show that these inputs go on, we use the ... to indicate that we can plug in all of the integers starting with 1 and going on infinitely long. If that's the case, if the domain does have those dots, then this is going to be an infinite sequence because the domain is infinitely long. However, let's say that the domain for a sequence is the following. Let's say it's 1, 2, 3, and 4. If the domain is just those 4 values, then that would be a finite sequence because it has a limited number of terms. Now, the domain is the set of those consecutive integers. The range of a sequence is called the terms of a sequence. So the range, remember, is also the outputs, right? So you plug in one of the integers from the domain and you get out a term of the sequence. So here's just maybe a little bit more of an organized way to look at this. If you have a domain of the following, these are of course your inputs of 1, 2, 3, 4, so on and so forth, until we just plug in any integer n. The range or the terms of the sequence would be called the following. If you plug in 1, the range is called a sub 1. If you plug in 2, that term or that output is called a sub 2. If you plug in 3, you get a sub 3, 4, a sub 4, and so on. If you plug in n, we call that term or that output a sub n. So one of the first things that I'd like you to be able to do, and you're going to see this when you practice in your homework in class, is I want you to write the first 4 terms of the sequence. So let's do that. Let's write the first 4 terms of the sequence. And we'll define the sequence in 2 ways. In part A, I'm going to call the sequence a sub n and define it as 2 times n. So, if that's my sequence, the first term we'd find by plugging in n equal to 1, because that's our first number in the domain. And so that would be a sub 1 equal to 2 times 1, which is 2. In other words, the first term, a sub 1, equals 2. When we plug in 1, we get out 2. The second term, we would let n be equal to 2. So, to find that, that would be a sub 2. That would be 2 times the input of 2, and we would get out 4. The third term would be n equals 3. That would be a sub 3 equals 2 times 3, or the term 6. And let's end with the fourth term of the sequence. That would be when n equals 4. That would be a sub 4 for the fourth term, and that would be equal to 2 times the input 4 for an output of 8. Those would be the first four terms right here, 2, 4, 6, and 8. In other words, the evens there. Now, part B, I'm going to define another sequence in a little bit different way. Let's call this one f of n instead of a sub n. I'm going to use f of n. And let's call this one negative 4 to the power n. Okay, so the first term would just be when n equals 1. So that would be f of 1. We're plugging in 1, and we would get negative 4 to the 1, which is just negative 4. The second term would be when n equals 2. That would be when we plug in 2, we would get f of 2. And so we'd have to take negative 4 and square it. Now, since the negative's in parentheses, it's really the product of negative 4 and negative 4, giving us positive 16 for that second term. The third term would be when n equals 3. This would be when we do f of 3. That would be negative 4 to the third power. When you have a negative to an odd power, that would be a negative output. That would be negative 64. And the final term we'll do is the fourth term when n equals 4. This would be f of 4, or negative 4 to the fourth. Now, a negative to an even power is always going to be positive. I think that's going to be positive 256. So that's the first type of example I would like you to be able to do.